question for 4F5. This was 4 people who responded to the survey said this was a difficulty. It says a bird has a speed in still air of 22 meters per second. On a very windy day, the wind is blowing from the east. The velocity of the bird as observed from the ground is 25 meters per second towards the northwest. Find the speed of the wind correct to 1 decimal place. So I know a few things. I know the velocity of the bird. In total, its magnitude is equal to 22. Okay. On this very windy day, the wind, when the wind is blowing from the east, the velocity of the bird, as observed from the, apologies folks, I'll have to make the absolute boo-boo. The 22 meters per second is equal to the velocity of the bird, but relative to the wind or the air that it's in. Okay, apologies for that. So the velocity of the wind, we said often if we didn't understand what it was, we said it was going to be xi plus yj. And then we said the velocity of the bird, and that's the velocity of the bird as looking at it from above. In this case, is going at 25 meters per second towards the northwest. So going that direction. Okay. So we might remember that the relative velocity formula is the velocity of the bird to the wind is equal to the velocity of the bird minus the velocity of the wind. We also might want to find out the velocity of the wind to say that, the velocity of the bird is equal to the velocity of the bird relative to the wind plus the velocity of the wind. Now, this is not much good at the minute. I think we have to draw a diagram of this. And when we do that, we'll see where we go. This is the velocity of the bird relative to the wind, and this is the velocity of the wind. The velocity of the bird is going 25 kilometers per hour, meters per second in a northwesterly fashion. That's that vector, and that's done. The wind we said was blowing from the east. So again, I'm back to drawing my compass points. It's blowing from the east, starting over here, and it's going this way. So it has no J component. If that's the case, that's the vector, or it's a representational vector I can draw. It's going to possibly end here. Now, they said it was a windy day, so I'm not quite sure where I want my vector to end. But I'm not sure of this, and it doesn't matter if you've done this a few times, you are not any better for declaring that it. Okay. So what we have here is our triangle. And when we fill in this triangle, we can have a little look at data. So let's put in names on these. So this is the velocity of the bird. That's as it flies. This is the velocity of the bird to the wind. And this is the velocity of the wind. And I notice I've just stopped using all my colors. But that's this vector. That's this vector. And then this is this vector. And when you add those, that's this vector. And when you add these two vectors, you get this vector. And that's true. So that's one thing. Now, let's put in the detail and the data I have on this. Well, we said the velocity of the bird relative to the wind was 22. The velocity of the wind is unknown, but it's only in the x. The velocity of the bird is 25. There's only one other thing I know, and that's this angle. And we know that's 45 degrees because we know that the wind is coming from the east, and so it's going only in the I direction, and that this velocity of the bird is going in the northwesterly fashion, and so it's this direction, and we know that's 45 degrees. I hope that's okay and clear. If we do that, then we can use our sine rule. So sine A over A is equal to sine B over B. Let's fill in what we have. We have this 45, so we can say sine 45 over the opposite side, 22, is equal to sine B. That's obviously the opposite side to the other side I have. And that's over 25. So 25 times sine 45 all over 22 is equal to sine B. There's root 2 over 2. So sine B is equal to 0.07. And the inverse sine of that is 45 degrees. So that's B. That's this angle there, and that gives us our direction. So my diagrams don't have to look right, they just have to be constructed right so I can figure out the solutions. So that wasn't the question. Anyway, it then said, so that's 45. It said find out the velocity of the wind. And this is crucial, folks, and I just have to highlight that again. Sometimes you can think you're finished, but actually we need to solve that. So this time, well, what's that? What size is this angle? It's 90. Therefore, oh, there's something wrong. There is something wrong. I know there's something wrong because we've got two 45-degree angles. And they're opposite each other. And these two sides should be equal. Anybody see my mistake? Maybe 22. That's that. Yeah, okay, I must have made a mistake. Let's try this again. 25 times sine 45. I'll check back on that on the video. Divide that by 22. That's not the same answer as I got. That's 803. Shift sine of that. 53. Ah, sure, yeah. Whatever. It's equal to 53.5 degrees. So this is now 53.5 degrees. So 53.5 degrees plus this 45 makes 98. Take that away from 180, and I'm left with this angle here not being 90, it's 81. So again, using my sine identity, I don't know what I want to do. Maybe sine A over A is equal to sine C over C. C is the curiosity. This is the one I want. So I'll just say C is equal to A times sine C over sine A. I've just rearranged that. In this case, A is 22, sine C, sine 81, and sine A is 45. I just made a boo-boo on this a moment ago, so let's hope I can get away with that. Can I get sine of that? Yes. Sine of 81 is 0.989 times 22. Now divide that by sine 45, and that's equal to 30.8. And that was meters per second, as they were also in meters per second. I hope that's